Okay, so in solving this system, I need to find the places where both of these things are true. So the first thing I'm going to do is just deal with them each individually and graph them each individually. So I need to look for their boundary lines. This one's going to be at y equals x. So it's just going to look like this. And then I'm going to pick a point on one side of the boundary line and plug it in. So I'm going to pick -1, 1. So y1 is less than -1. This is false. So that's how I know that I should not shade in this side, but rather I should shade this side in, because this is the side where it's true. And you can double check that by plugging in another point. Like you could plug in this point, which would be 1, -1. And if you plug that in, you get -1 is less than 1. I'm plugging it into here, and that's true. Okay, so then I look at my boundary line itself, and because this is a less than sign and not a less than or equals to sign, this is going to be dotted. Okay, so we did that for, oops, shade that all in. Okay, so we dealt with that first inequality. Now I'm going to do the second inequality. So my boundary line is going to be 2x plus 4y equals 4. I'm going to get this into y equals mx plus b form. Okay, so y equals 1 minus 1/2 x. So my y-intercept is going to be 1. And then my x-intercept is going to be 2. Draw a line connecting those. This is my boundary line for that second inequality, and I'm going to test 0, 0 to figure out which side of these is true and which is false. So 0 equals 1 minus 0 greater than 2. Okay, so 0 is greater than or equal to 1. That is not true. That's false. Meaning that everything on this side of my boundary line where my test point is going to be false. Everything on this side is going to be true. So I shade this side in. And then my boundary line itself is going to be solid because we have a greater than or equals to sign. Okay, and then the final step is just figuring out where both of these things are true. So you're looking at the spots where you have both an orange shade and a purple shade. So that's this here, along with this line. So this line is included, but this line is not because it's dotted here, but fully shaded here.